to lead. Then I think there's going to be a group assignment and individual assignment.
Okay.
Which I prefer the one next Saturday and Sunday. Yeah, I said it on my email. Okay. Kana munyasi ko anida itu aisiwa kedian.
Alright.
So I was give my email ya the phone number maybe. Yeah, right. Like the topic says advanced condition monitoring of machinery. So basically CBA is condition based maintenance. In other words, I think these names were done to try to dovetail with the new curriculum, but you find sometimes the way the modules were coined, they end up being a chapter if we are not careful. But I will try to zero on CBM and the trends thereof. I think that's what is important at this level, right? With the understanding that we have already done some basic work on maintenance. Do you have maintenance in this
No?
course?
No.
With engineer Mugindiri? No?
No.
Do you know engineer Mugindiri?
No?
Oh, you know him from somewhere. Yeah. This is one of our best fundis on maintenance.
Okay.
Yeah. The brief history about engineer Mugindiri is that he finished his degree, first degree in mechanical engineering in 1986, 87, thereabout, and he got a first class in mechanical. That yeah, is quite powerful. It's quite powerful, right? So you would say when you are laughing, you say, I'll drink beer and wake up at 1 o'clock. I work from 1 to about 5 a.m. That's when I perform better mentally. But so it's right. But my is heavy these days. Right, this course provides a range of topics on condition monitoring for engineering assets. It covers condition monitoring of key importance, its benefits and techniques. So you find zero on techniques. Just write what interests you because most of this stuff I'll give you. But this one you got from Munyaki.
Yeah.
Alright. So zero benefits, techniques. Yeah, we'll look in detail techniques. If time allows, we'll try if we can see if we can have discussions. Then visual inspection techniques, non-destructive techniques, analysis techniques for wear and debris, contaminants, lubricants, condition monitoring of electrical machines, vibration analysis. It also covers how to identify fault diagnosis techniques applied to condition assessment activities of system components. Right? Basically, it's just an add-on on good maintenance systems. Right? Recently, I'm involved with selling some products. They are lubricants. So sometimes I take these young people like this guy. I think I just go to tenderera. My plants now. Then you told them to then the young man of so what maintenance system are you using here? It's like I'm thinking of more. So that he can expose that because he wants to make sure that I think I'm But we industry are going to maintain the system. They do everything to survive. I can tell I question which go right. So they do everything, right? So the outline simply introduction to the maintenance or maintenance simply vibration theory, fundamentals of data acquisition, principles of condition monitoring, transducers for condition monitoring, fault diagnosis, rotating machines, NGT methods in condition monitoring, where debris analysis. We just try to be as brief as possible on some of those things, because since I'm just trying to draft content, you find that we divert sometimes, seeing what is necessary to talk about. Case studies in condition monitoring. At this level, I think it's key that we learn from case studies, right?
Yes.
With situations, so that you don't memorize to say which type, isn't it?
Yes.
Yeah. It's always a hybrid of other things. Then references if you have time. But what I encourage in this regard is that just read the material that I give you. Then you avoid wide reading. It may not be necessary. Yeah. If your term is quoted in mind, it's not. Because get to the point, they are quite comprehensive notes. Yeah, they're quite comprehensive. Yeah. And what I want you to be doing is please try to organize meetings, groups, and discuss questions, discuss the concepts and all that. Okay. I think I have one tutorial file where there is a lot of these discussions you can have. Get the highlights. All right. Mostly, I think for these small groups, I'll say your assignments and your individual assignment and group assignment, you send it on that email. It's imad@gmail.com. Right? It's more reliable. Then those are my 2 cell numbers. The other one is on WhatsApp, the one native on WhatsApp. Right?
Can I have the first slide, please?
First slide.
Yes. Yeah, just one that one. No, not that email.
Oh, that's the number. Alright, it's fine. So condition monitoring using all the what we want to zero or what we want to differentiate is the common trends. How is artificial intelligence coming in? How is industrial Internet of Things coming in? Everything that we learned from Prof. Michelle, right?
Yes.
Yeah. For your own information, we applied together for promotion to become professors. I wasn't so lucky.
Okay.
Yeah. So I resubmitted the rest of the end of next year. I always laugh at myself. Then I always console myself. But I'm also human. Humans fail. Right? So, Prof. Michel is more into robotics and all those things, and this is where the industry is drifting towards. And when we are saying industry, it could not be locally, but globally. Yeah, because all those things are also now affecting us, isn't it?
Yes.
Yeah. I think I have one with time and more time, but I'm going to give you in Germany, I think, with cases of about 5 companies which are now like now on intelligent manufacturing, right? Everything's just happening. The maintenance is just happening. There's a minimum human interface, isn't it? Yeah. So this is what we want to relate to as further trends. Why I want to talk these guys is that when it comes time for you to choose your dissertation topics, you must know to say this concept is now a condition monitoring. It's now going to the age where it's automated. And then after automation, we are told this component is going to fail within this period. The action that is to be taken is A, B, C, isn't it?
Yes.
Yeah. So all your things you learned about deep learning, whatever, incorporate it in there, isn't it? Yeah. Right?
Yes.
Okay. I always want to refer to these things. Those are my qualifications. Potential kumusha. Ngotia kauya gazi donzi Mr. Magicians to Vaenda. Achikufratira. Vananobva Kitson! Chichabva chiruka. Sitena mwana nezidaramu. Atikuziva izvi kuzoti Mr. Magicians. Chakuto Gibson. So it's important to give people all the profile, isn't it? Yeah. Right? Okay. So that you can keep so and so. Okay, let's go. Condition monitoring for intelligent machines. Basically, what we wanted to be talking about how now sensors are getting to be used, that advanced sensors and signal processing techniques for machine condition monitoring. Then with a typical machine, we now have things like motor current being monitored, loop oil being monitored, the lubricants area, it's my area, this one. That's what I know better. Then there are issues like thermography, where you monitor the temperature. Performance monitoring, probably this could be output. It comes when we are failing to keep performance indicators. Your pressure, when you are talking about probably your pressure vessels, your boilers. Vibration, right? Which may actually the movement of rotating shafts, fans, whatever you may think of, right? In every case, please, let's say if we are talking about something, let's think of examples. When Lever Brothers was still operational and the big explosion in one of their boilers, and one of the artisans was thrown through the roof and was picked up in tatters on a right road. My 90s, that is. Do you remember that incident? We were outside the country that time.
No. It was 90s Form 1. Like 90s Form 1.
Form 1.
Yeah.
Alright. But see, it's evident.
Oh, yes.
Yeah, you can always find out about. See, but I don't know, I can't tell you. So,
it was Unilever.
It was Unilever. That time it was doing a lot of manufacturing locally. Right? It was before, it was before my sanctions. Because most companies that was a mass movement outside the country after 2000 when reform. But before that, most companies were doing serious business, right?
Yeah.
So whether we live is still there, but as long as with companies we are using boilers, they need to be closely monitored, right? And sometimes when something is about to fail, it doesn't fail overnight. It gives signs and symptoms that something is about to happen, isn't it?
Yeah.
Yeah. I always want to talk about this. My experiments at Emboita Money, I think past one engineering, I think it's about it, isn't it? Just simple. But it was like, was it force here? Correct me if I'm wrong. But then I think this is the diagram will go like a straight line. This was like a plastic pocket. Then it would go like this. What was it against what? Extension. Against force, something like that. Is it? Still remember this? Where we say this is the elastic portion. Then there's that, then there's the yield. You see, all these are signs that something is about to happen, isn't it?
Yeah.
Right?
Yes.
So we are saying if we could pick something during this, probably if this is a mild steam or whatever, before it breaks, let's get that information, isn't it? Okay. So basically what we are talking about are just condition-based monitoring strategies. Now, like we say, it's leading to age sensing methods, advanced signal processing techniques, and we go to our condition monitoring procedure and system integration. So every time let's think of a system, isn't it? Right?
Yes.
You guys, you are privileged in the sense that we are strong in electrical, isn't it? And also, I think the background that we have been given on artificial intelligence, Internet of Things, and we now come up with design, come up with a system of condition monitoring. If you don't want that, you have a system where you think you want to monitor something. There are now vendors, a lot of them, isn't it? Yeah. You tell them what you want to be monitored. Then you retrofit that particular thing. And we are not saying do everything. Pick up using the 8-20 rule. 20% of your equipment is critical. Why not zero on that? True. Yeah?
Yeah.
Okay. I'm told it's very difficult to fail these days because 50% is your coursework. 50% is your exam. Come with a 30 months or more than 20 exam. You are there. Right?
Yeah.
Yeah. So, like we've agreed, I think because we want to finish everything today, the test is no longer there, it's now individuals. The test is now going to be the individual assignment. Then we can now increase, probably make 2 group assignments, maybe. We'll see what we'll finalize on. Right?
Yes.
I think we've talked about this in the course outline. These are subject to change. So it's not strictly this. Because what I want normally when we're doing this thing, let's try to zero on practical issues, examples, a lot of them. Right?
Yes.
Yeah. Because for me, normally when people are doing projects or dissertation at this level, I want people to zero on case studies. Right?
Yes.
Those are theory, and what we want are case studies. What do you learn from this case study? How unique is this case study? And you can tell people, according to the case study that I did, that the authorities isn't it? Yeah. Because when I do zero on theory or not, that destructive techniques, it's tired, it's a tired area. Alright?
Yeah.
You end up, you go what do you reproduce what other people have done. So let's think of case studies. Which industry are you interested in? How does it, according to the lead material that we've covered in this subject, where do you think can be a gap? Right?
Yeah.
Okay. Because I think last group that finished with Washington DM. Yeah. Akatozokuzada kupedzera nomazva eCovid. Akangoti ndikuti supervisor, I want to do something on condition monitoring at Manitsi. Manitsi kwake kune security issues ndakuita kuita zvakadhana kunzi chii tunayo road
Drums. Verify.
Saka ndo yakazopedzera akuita nayo. And we never met because of COVID. Saka
But you completed successfully.
Successfully. There is a big plan for Air Force. I think it's what do you call them?
I'm not sure.
Wing commander or whatever. I don't know what they call themselves there. Yeah. So it used to be quite jovial over the phone. Yeah. Right. So think of those things. If it interests you, I always propose you get a case study. Case study, you read your literature, you see, you feel well, you feel there's a gap, right? You go and start case study, just start how things are done, right?
Yes.
And where you think this concept can be implemented, how can it be implemented? Are they implementing the concept? And if they are doing it, where are the gaps in their system? Do you see it's getting more and more practical? It's quite interesting.
Yeah.
Preferably where you are working or where you are affiliated, isn't it? It becomes very easy. Because you know the place in, if you don't have access, you can always look for information. Because these days people, they are so secretive about their companies. Because there are a number of things that are happening. Right?
Yes.
Okay. And one of the things is power shortages. Yeah? Mazoona woku national hakubuda uchiadresa kuti 5 days, you have to go home, blah, 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 blah. Did you see that? That's it. We saw Garba.
Which group?
I remember no put our It's like the CEO of Nash Group was saying 5 days without baguettes. Psychiatrists are my waiters.
Oh, okay.
So you have to go home. Those who are going home, your supervisors are going to advise you. So it was viral and I bumped into it. But he was complaining that time, and now I guess they are worse than that, right?
Yeah.
Yeah. In most companies, they are now on generators. I was at Zimbabwe, I was at Zimbabwe, I was at PPC, Blair, they're just generators. You go to Coca-Cola, they're just generators. Yeah. So when we are discussing these things, there are other things that come in. And if your conditioning monitoring system is dependent on energy, and electricity is not really available, it's a serious factor, isn't it?
Yeah.
Yeah. So case studies, they bring us very close to what we want to do. So here they are saying condition monitoring is just by way of definition. It's also known as condition-based maintenance, DM. Most equipment failures, they give warnings, and they are about to occur. What is that one? It's it's when you are scheduling something, isn't it? Normally tough material, they yield before they break, isn't it?
Yes.
So here we talk about potential failure. Alright, I'm going to more brief. It is defined as identifiable physical condition which indicates that the function failure is either about to occur or is in the process of occurring. Alright?
Yes.
So techniques to detect potential failure are known on condition management tasks because components are inspected, left in service on condition that will meet a specified performance standard. Right? There are times when people they sacrifice components if they don't want to stop machinery, isn't it? Then they sacrifice. I know I'm not good at telling my way listening. But you know, my way used to operate Shabani and Mashaba mines. You know that?
Yeah.
Yeah. And he was operating like 24 hours. And he had no local warehouse. The fiber was coming from the machines loaded onto the trucks. The warehouse was somewhere across the border in South Africa. And they are still selling that fiber up to today. Because he was just doing that. So, that time I was selling lubricants to the mines. So they would say they were using more lubricants than the fuel on the machinery ground. Because it was a conscious decision. So we don't want to stop this. Right? So my LHDs are operating 24 hours. No workshop. Just put the oil in there. Because the group CEO, that's what he wants, isn't it?
Yeah.
Right? Okay. So, but we are saying condition monitoring, that was the technology. Why did we try it? Then also I don't want to assume that you know what maintenance is. But here, let's try to define it. Maintenance is undertaken by organizations to try and avoid failure by taking care of physical facilities. It's a critical part of operational activities. Right?
Yes.
In other words, we want to extend the useful life of an asset, isn't it? That's why we do maintenance. Sometimes we repair buildings, sometimes we repair those aircon. When we part 1990, they were functional. It was very cool in here.
It was cool.
Very cool. And these classes were for the part 4s, part 2s, part 3s, yeah. The part 4, yeah. You know, the higher the level, the smaller the class was that time, yeah. So we can say this is in its current condition because of maintenance process, isn't it?
Yes.
Yeah. For talking of a human being, when you are looking so fit, it means you are visiting the doctor more often, isn't it? Or exercising the morning. I know it's supposed to, but you can't sometimes forget. Right? So it's all those exercises to close up the facility so that it's in good working order. Like in Zimbabwe, where most of our equipment is so obsolete. We talk about windmill and ZFC and cables and Sebo. The original specs of the machine has since disappeared because of so many modifications during maintenance. Yeah. This other day, it was this past week when Mr. Interaction, then the guys I work with, they are also into hydraulic system hosing fittings. So we saw showing this machine. It was in a vehicle truck. It had this tailgate lifting mechanism. Okay. So the feature whom I was moving with was saying, please can you open this so that I can see the side of the inside plating because there are so many modifications of this fitting. So I want to see what was the original trading site. So this is typical of our environment. Yeah. So maintenance becomes a big issue. So how we close up, or how we try and modernize our systems is very important, right? Operations like power station, petrochemical industry, mining, process industry, hotels, airlines, maintenance activities will account for significant portions of operation management time. Attention and resources. So the organization of maintenance policy is termed maintenance management. I think we have quite a number of softwares, isn't it? Which ones can you think of? Maintenance software systems. You think about that, isn't it? Right? So maintenance is part of ensuring adequate that the equipment is adequately and self-functioning, because like we talked about the pressure vessels, safety is an issue, isn't it? Yeah. Right? If something happens and somebody loses life, bad coverage of the company, when an answer they will descend on you, a lot of people will come there, including Emma. Sometimes they will see where they get fit in. It costs time and money in performing the repair, restricting or interrupting the system's functioning. Well-founded maintenance is good engineering practice, right? Whereas unnecessary maintenance is not only a waste of resources, it's also detrimental to the functioning of the system, right? Sometimes we have regular or periodic or planned maintenance after 3 months, after whatever. Sometimes it's detrimental, isn't it? Yeah. So this is why condition monitoring is becoming an in thing. You can call it predictive maintenance if you want, isn't it?
Yes.
Yeah. Okay. So 1 to 0, what procedures are necessary and when are they necessary? And what are the factors that actually we are going to consider to necessitate that? Right? So the young man I was moving with during the week, I think I'm going to slide here. So we want to ask what type of abilities do you use here? Yeah. Okay. Breakdown maintenance, right? Characterized by unpredictability and firefighting arrangements. People are trying to move away from that, isn't it?
Yes.
Yeah. There's always this, did you do production as a subject? Production didn't do that one. Right? In production, we say there's plant capacity to produce, and then there's demand out there. What is required by the market? So sometimes the market becomes overwhelming, that there's high demand and your capacity is very limited. So if you don't know the design capacity of your plant, you tend to avoid maintenance. You think it's a waste of time. But we are not saying how much is the capacity, the design capacity. Instead, what you should do to meet your high demand out there is outsource. You can have a project to expand your plant instead of sacrificing maintenance of activities, isn't it?
Yes.
I will give you a good example. Do you know that Pepsi, they have a very huge capacity to make my pet and all that? A very huge capacity. That the demand is very small.
Okay.
Yeah? So this is why they have all those promotions. dollar, is it 50 cents per liter? I have 2 young boys at home, so Takawana is 50 cents per liter, but I want to be ragged. So when we got home, the mother was surprised. Because kuchaishi, because you know, probably promoted, so it's a number of 500 bills. So it's a way of actually promoting, excite the market, so that you grow the demand. And it was for 500 bills, it was $1 for 3, isn't it? Remember?
Yes.
You are exciting the demand so that your capacity, you maintain your capacity. But sometimes the demand is very high. You have to play around with your capacity, make plans. What we are talking here is systems, way of looking at things, right? That's your area, isn't it? Yeah? Okay. In the process, what is PEPS doing? It has put too much pressure on Delta, if you have looked at it. Right? Capital was the dollar traditional is now 50 cents. Yeah.
Actually, it's now Coca-Cola putting more pressure on Pepsi. Because Pepsi have taken over the market.
Yeah. They've taken because they are supplying about 80 to 90% of the market. Yeah. You see. And also, guys, when you're in production, always know that somebody is watching you and is working on you. Right?
Yes.
So, this is why I want to talk about these things of doing maintenance. Probably, perhaps there's a fairly new plant, there's a fairly good condition monitoring systems, because it's the Indians working on who actually installed that, and they installed the fairly new equipment. Alright? So there are level of breakdowns and whatever, and there are modern systems, they are fairly modern. Right? Okay. So, but then what our bow. It's kind of do like Delta, my guess. So, some of the shareholders in PEPS, they wanted to sabotage Coca-Cola. I know this about it. It's not true. Right. So, but whatever you do, know that competition is doing something. Delta has been doing well, but you don't just have to feel good to say, no, that someone is watching you, is actually coming out with a better product, better systems to beat you. It's a reality. Yeah. Okay. Then break down price management, just that. Schedule preventive maintenance, this is your planned or periodic, right? Yeah, this is what we seek. Always you go into these big operations, you find maintenance planner. It's always there, isn't it? Maintenance planning manager, all those things. That's what they look at. I know during my time when I just joined the industry, when one colleague was so productive, there was one guy who was called, what's that saying? Muru, do I really say the name? Muru was so powerful. He was a senior artisan, one colleague, and he was the maintenance planner. So powerful. Until I was one of Musa, he tried to put that in drum like oil. What Muru, I remember also Muru about, you know, anymore. It was open, workshops, offices. So what they will do, if you delay that time, if you delay that time, they will let you go with the late inside. Then what would happen? But sorry, so you have to pay a fine. The fine is 2 crates. One for the one crate for the one breast. So they would get this crate for get a crate so or every Friday they would have a drinking time. It was so fun. It would be interesting to go there today because now women are all over. So now from preventive, we go on to CMB. This is monitoring of operating parameters. Which are the common parameters, guys? Just off the cuff. Temperature, vibration, what else? Pressure, oil condition, isn't it?
Yeah.
So this is what all this subject is all about. It's not a difficult subject, isn't it? Right? But I want you to think of this in terms of the systems, how they can improve the system operations, isn't it? Right? Then, here they are saying condition monitoring is a form of scheduled maintenance. Sometimes it's referred as predictive maintenance. So CMB and predictive maintenance should be one, isn't it? Right? Because we are saying we are monitoring some parameters to give us an indication that that maintenance activity or processes should fall due sometime in the near future. If we don't attend to that, then we are going to have a breakdown, isn't it? Okay. But as we are thinking that, you guys, because we are grounded in electrical and electronics, sometimes we get false alarms, isn't it?
Yes.
How can we avoid those? We have to know the system, our system, isn't it? Yeah? We have to know our system and the causes. Right?
Yes.
Okay. This is just a common graph. I think we have seen it from somewhere. Where we are seeing probably the equipment is failing. I think it's the time period there during the lifetime of a piece of equipment, right? And then probably equipment availability or reliability if you want, right?
Yes.
So we are saying during this period the equipment is fairly new. Probably this is where planned or preventive may work, isn't it? But as the equipment starts having some challenges, we start monitoring our vibration, our sound, our oil analysis, our temperature, probably produce some non-destructive tests here and there, right? And sometimes, like the equipment we have in Zimbabwe, John raise the hand, check what's right. What's the smell? Where is the smell coming from? You know, that kind of thing. Does it mean I get a Yeah. So all those things. So we are saying we are here, guys, and we are trying to interrogate that to say these parameters, they are within corrective ranges, isn't it?
Yes.
Yeah, that's what we want to do. And we want to avoid that. But know at the back of your mind that in Zimbabwe, most of our equipment are within that range. Sorry?
The last one.
The last one, most. Move around if you want. Go to the mind if you want. But probably when I maybe around here, maybe there are some here. in some of the pieces of equipment here they have, right? I think vanakoni takasvika kuno, I think. You can think of anything, right? Think of anything. PPC, they try, I think the Marasasa one, I think they are somewhere here. Because it was fairly installed, I think 2016, 2015, right? Okay. But they are now on generators as well. Lafarge, which is now called KIC here, they are not worried about it. Right?
Okay.
And one other thing, guys, if you are advising a company, you are called an engineer, you have been advised to say, can we buy this entity? Be honest, guys. On several occasions, apana gearbox originally correct specification. Kukai. I'm not trying to be anything to take away from them, but yes, it had a good name in the past. That's what people are buying. But if you buy prepared to offer one which is expensive, why don't you just apply and have a new plant since we have problems of cement? And to show that recently we had shortage of cement, isn't it? Yeah. And we are told that 6% of cement is imported from Zambia. And from Zambia, you can rent it here $7. You sell it at $9, $10, still make money. But during shortage, they sold it at 21. So they made about how much? $14. It's a lot. It's a lot. And we are also told that even Lafarge itself is actually buying from Zambia in bulk and repack. I know PPC, some of the cleaner that they use is from South Africa. So there are a number of things happening around us. Okay. Right?
Yes.
We do appreciate this diagram. Right? Those are just some of the activities that you can look at. Right? I think condition monitoring is about some metrics, isn't it? We are looking at parameters. It's some standards. Right? Yeah. Okay. Right, these are just some of the pieces of equipment that you can look at, right? Okay. Your pumps, your fans, gearboxes, compressors, engines, steam turbines, if you say in some of the power stations, generators. I think generators, diesel generators, they are in thing these days, isn't it? Yeah. Because I was asking the guys, the Victorian Zimbabwe, they say we were having about 7 very big ones. Yeah. Okay. So they are also coming in there. But tell me, guys, with solar energy, why are not people using solar and resorting to diesel generators?
So it's such topic. Very good one.
Maybe Nyema policies.
Policies.
Is solar not effective enough to generate?
It can.
Yes, but I think the capex is
You would need a very huge.
because on the battery side.
Storage facilities.
Yeah.
The challenge is on the storage of.
Yeah.
Yeah, think about that one. Yeah. Think about it. Yeah. Because honestly, we are on the hype about the solar energy, and you think something is being used. And it's not. And investors are coming to invest in solar energy. What really are they trying to do? Why is it going now? Almost every serious industrialist, they are on generators.
Yes.
They are on generators. Okay. And this is what people look at when they want to invest in a country. Right? Availability of power. Remember about Dangote. We wanted to have a very huge cement plant. I'm done, Mama Kura, Dangote.
It's recent.
That's very recent, isn't it?
That's very recent.
Yeah. And
So did you complain about energy issues?
no, he's very clever assessors. You will send this team, find about policies, find about energy, find about the markets. Policies is one. We change my statutory instruments here and there frequently. I think the latest was to say we've extended the dual currency from 2025 to 2030. And you go to the bank, my bank, they got confused. Should we give people my loan? Yes, should we? Yeah, it also affects those guys. And also our market. We're just a small market.
Yes.
Very small. Yeah. So Dangote is in operation in Zambia. So probably probably Zimbabwe supply the
I think you are also looking at it to say please already supplying Zimbabwe market.
Zambia.
And they're almost good enough,
Yeah, maybe. Yeah. But power was also one thing. So I think the thing was the condition was, please can you allow us to have gas, then we can have generate our own electricity and use. So then we are guaranteed this power. Yeah. Okay. So think about these things. At this level, guys, think the whole system. The whole system. We are not yet passing. Passing is already passed.
I love that one.
Okay. So, condition monitoring, sensors, analysis of data, safety relevant damage can be detected any so that corrective measures can be taken. This paragraph, deviation from the recorded data, maintenance schedules can be done before fault speed production. Also to want to prevent unplanned shutdowns, total machine failure, right? This you can read on your own, isn't it? Please, when you go through these notes, make your own notes, isn't it? Alright? Okay. So, condition monitoring refers to continuous monitoring of equipment state and operating parameters through dedicated sensors and monitoring tools. You have no problem with this one. It identifies stages that indicate damage. In terms of fatigue failure, incorrect configuration, I think this is where your vibration comes when there is a misalignment. And other safety impacting conditions, when we're talking pressure and pressure vessels, right? So repairs can be done before failure gets a chance to occur. So this is what we are safeguarding against, isn't it?
So the Union case study there, what was the issue in terms of with regard to the maintenance part of it? Were they not monitoring the parameter? Or is God safe? I'm not sure.
I don't know really what caused it. It was then that time, and that time I think most of the operations they were all well maintained, and I think they kept it a secret. I'll say what happened. but definitely there were some penalties, the bad publicity, the reparations to the families affected. If there were others who were injured, to look after the family, to send their kids to school, to do all those kind of things. It's so nice. It's not so nice. Yeah. So at the end of the day, you say we talked about procedures, isn't it? What does the procedure say? When was it? When was this last inspected? Why did you get to that point? I think there are NASA guidelines on pressure vessels. You know, a lot of things. And you find that probably there was an oversight on the inspection side of things. Yeah. Okay. So sometimes you can't pinpoint. I know the common accidents that we normally record in the country, they are only in the mines, accidents in the mines. But every day when you open a new place and you splash that, you put roll balls, you secure. But somebody has been allowed to go in that area before it has been secured. Something like that. So it's a procedure, it is not proper. Never manager who give people a pressure and force carriage. No, it's fine, do it. I said do it. Yeah. You see, that kind of thing. So let's get our procedures together. Parameters also indicate components that are most likely to be fault enabling engineers to plan and target their maintenance operations with more accuracy. So we've talked about the 80-20 rule, which are the problem areas, problem pieces of equipment, isn't it? Let's zero on that instead of wanting to monitor everything, isn't it? I'll give you a simple example. One Korean, during its heydays, its most critical part of equipment was the 200-tonner dump trucks. They were Caterpillar at that time. I think they had about 26 of them. Very functional, very big. Right? So that is the one that was going to collect ore from the pits to the processing plant. Because normally coal, when it's mined, it's very volatile, it has gases, just starts burning on its own. So the processing plant is now, they wash it, they get the proper pebbles, they crush it to the size that was being used by ZESA, isn't it? And it was the sole supplier of coal to ZESA. Right? So the dump trucks they are critical. And then the other critical piece of equipment was the drag line. The white one. The drag line was the one which would like open up. It was a very massive agricultural reaper the top soil subside and start digging. Then start scooping and putting in those 200-tonner trucks. So what they did, I won't talk about the drag line, I'll talk about the dump trucks. So what they did for the dump trucks, for the engine oil, every 5 days, they would take a sample from the engine, from the hydraulic, from the gearbox, then they would send those samples to tribology. Right? To say it's the oil still in order because the environment one is hot. This year I think the clock is 40 degrees, if not 45. And then the operating environment was very dusty. And these pieces of equipment they operated 24 hours per day. Right? So if this movement of ore wasn't to happen, then they were going to have challenges them against, isn't it? Yeah. So they used to zero on the dump trucks.
Okay.
Yeah. So every 5 days they have to know the condition of the oil, and if they feel there is something wrong, has been picked by the tribology guys, they will, that time there were no emails, so they would fax to say, please stop this machine, right? We've picked some silicone ingress in the oil. So that piece of machine should go to the oil shop, drain the oil, check to see where the dust has come in, isn't it? So instead of just saying Ramadani, it doesn't add value.
Yes.
Yeah. So critical pieces of equipment. Okay. So think of the examples of where you are working, where we are associated with, isn't it? Yeah. And to say what are the critical pieces of equipment that you have. If you go to a mine, any mine, especially the underground ones, mine manager would afford to have a cup of coffee in the morning as I end up class. Because you not around that headgear is turning. If it's turning, it means ore is being, it's coming out of the ground, and people can go down to work, isn't it?
Okay.
But if it's stationary, I don't think I will mind oh, because the other one was numbers over. We would ask the engineers, what's happening? Where is it stopped? Because it was a critical piece of equipment. Alright. Think of all those examples. What can we other think of? Just give you an example. Pazesa, tomboti ma power plant by essence, what would you, general manager of that plant look at? What time is the down to farm? Has honest team which would have was going to be worried that of the cooling towers. I did something is not well. Yeah. And you could have a meeting, so everything is quiet. Yeah. Okay. Think of all those examples there. Then let's go to this one. Condition monitoring pinpoints damage or changing failure. It enables operators to identify and correct problems through repair and maintenance procedures before they cause equipment failure. That's what we don't want. Equipment failure. Or want to mitigate the failure or the possible or potential failure. Right? Traditionally, this is what we use, condition monitoring techniques. We use the human senses, sight, sound, smell, and touch, isn't it? Yeah. I remember Dunlop, before Dunlop closed, you get a phone call to say, come, our gearbox is heating up. We change the oil. So at the end, at the moment, there's also to a tear or reader. Then also from what oil is put in there. Sometimes it was a very thick oil, so it tends to churn out and generate heat on its own. So we would recommend them probably to go to a less viscous oil and they will operate for some time before it heats up. Probably issues of bearings, alignments, gears. It was quite a number of things. but it's time concentrate, but I don't take this anymore. So guys, if you are operating in the businesses, have more information, because people will sell more to you without solving your problems. Right? Right?
Yes.
Then now we need special instruments. Yeah. Vibration and temperature. Effects to be monitored, dynamic effects. I think these are rotating pieces of equipment. Particle effects. This may be what is being released into the environment. I think this is specific to when we have discharge into the environment, like the cement plants. You remember when we were getting into blue oil, PPC, where's that saying that should blue oil? Everybody.
Dust.
Zvimiti zviripo zvokonyara but they've rectified that now. Ukadarika nepasipindiro kune ZFC, chero wakatsinzinya usiku mumurima, ungoti akasita kudarika pasi, because there are certain fumes which also going into the environment. I think they are working on that as well. Chemical elements release, physical effects, physical failure, I think we've talked about that. Temperature effects, rising temperature of equipment, electrical effects, changes in resistance, conductivity, electrical strength, and potential. These I think for electrical motors, isn't it? Where these are issues around insulations and all that. Alright, I think this one we've seen before. These are just the techniques within that range. We've talked about this range before. Right? Before failure occurs. So we are saying whatever monitoring you are doing, please let it give you a signal within this range, isn't it? Right? Because beyond that, it's now a breakdown. Okay. So be familiar with this P-level curve. I think we will read about these guys. So it's about sensing, thinking, and acting. So whatever system you are going to do, speaking the problem, analyzing it, and take action. And in modern plants, we are saying it comes to your screen and it should give you the answer and what to be done, isn't it? Who is the possible supplier of what is to be done and all that. Okay. And this system, guys, is you must have strategic suppliers of equipment or even contractors who can rectify that. Right?
Yes.
Yeah. And have partnership with those people of some sort. Okay. You go into almost every mine or every cement plant, you see bolt guys there, isn't it? What is the bolt gas? It's a mechanical contractor, they do a lot of things.
Okay.
Yeah, do a lot of things. You go to Unki, Mimosa, wherever, you don't miss them. Okay, I don't know what their secret is. Right? Condition monitoring is just further data collection, monitoring, interpretation of data, and action is done. Right? In the interest of time, those are the kind of benefits of condition monitoring or condition-based maintenance. Reduce number of failures, improved availability, reliability, worker safety, of equipment effectiveness. I think you know that from somewhere. Minimize time spent on maintenance. You can actually play around with your repairs and do them during non-peak times. it has been very hot this year. And people who sell cool drinks, they make a lot of money, isn't it?
Yeah.
And if they have a breakdown, they don't know what to do. Or if they think something is, they will say, please push, because we have so many orders, right? So they would prefer to do it not June, that's why they would prefer to do their services when it's cold and nobody wants cool drinks. Also, issue of extended asset lifetime, equipment performance, overall equipment effectiveness, availability, all those parameters we can think of. Minimizing inventory costs. When we started working in the early 90s, you go to any industry or any mine, there's a very big yard where they would put spares, right? If something fails, they will just go and fit in. But these days, money is so tight, you can't afford that. And we are saying, let's only stock the most critical space and let's minimize inventory. And do you know what happens sometimes? The economy used to go through very clear cycles of boom, it's boom, and decline, isn't it? Or boom, recession, boom, recession. At this point in time, what are we going through? It's a recession, isn't it? But it has been an extended recession since 2000. So what used to happen during boom, the engineers, the operations manager were in charge. They would tell management what to do and the whole company what to do. But when there's a recession, it means money is tight. So the financial people yeah. So since 2000, financial people are they're writing on you guys. They're telling you what to do, where to buy from.
Yes.
Yeah.
Okay.
Yeah. So what we are saying now, then this issue of minimizing inventory is actually a financial driven. Because it's about the resources. We don't have resources. We want to pay people, we want to pay our obligations, the market is shrinking. These are the real things, isn't it? So we have to minimize inventory. And comrade engineer come up with a plan to minimize costs. Right? It's a reality. Do you know the current minister, Chitani, is an account specialist? Do you know that? He's the one who opened Mimosa Mine. Yeah. The first mine manager to be called a mine manager with that background. Yeah. So we used to go there when they were trying to start the operation. Then then he would say, who is the mine manager? Then one young guy said, don't you have a mine manager? So what do you have? Because we have a bean counter. It was the bean counter. It was about bean and guy to put But the fact remains, he was calling the shots there.
Yes.
Yeah? He rose through the ranks and until he moved over to Simplats. Yeah.
Okay.
So these are the kind of people we want. I think Member is also an accountant, isn't it? He's the CEO. I think he's now the CEO of Simplats, isn't it? Yeah. Yeah. So they are calling the shots because we have to minimize inventory. So we are saying our CBM should also support that. Right? Okay. As a society, you don't get those things. Asset availability will be increasing, this plant availability, over equipment effectiveness, maintenance costs will be reduced. That's one of the things that we want to aim for. Performance will be improved. Output, right? Because it's readily available, per day we produce so much. Operation of assets will be safer, right? Like the Unilever incident, probably it took some days to replace the vessel to let the authorities come in, clear you, to say you can go on with the operations, isn't it? And also to instill even a sense of safety within the remaining workforce, isn't it? Yes.
Doc, I wanted to ask you, how is the she environment in mining companies? How is it being addressed? Is it are the numbers of injuries decreasing or increasing in industry and machinery related, be it mining, especially mining?
I wouldn't know. Because I think the proper mine actually last year some incidents. I think it was fatalities. I think in most. Yeah. Then it was a collapse of the mine, but another ends with my mine is implants.
Okay.
Yeah. I think this was to do with the fragile ground. So I think the mines they do their level best because safety is over encompassing from the top level of guys. And here and there are all small incidents. Why? Because there are operations there, it's a project every day. Exploring and blasting new areas. That's what they do every day. Drilling, putting Maora explosives. As we are doing the explosives, they shake they shake the ground and all that. It's the nature. So that's why they are upbeat about upholding safety issues. And as human people, they can do it that's successful to some extent.
So
We can't shoot them. They try their level best. But what we hear, what is in this mind, Makorokos are type of thing that we now hear almost every week, isn't it? Yeah.
No, even with
Manager there,
the
supervisor there, apart. Safety doesn't operate that way.
yeah,
But we have a lot of those now.
I've seen the she department, you never get the true numbers of the injuries which are happening because it has a direct impact on the general
Perception of the
yes.
camera.
but isn't it that if you want such information, if you go to NASA, they should have that for you.
But that information is
That information is coming from the mine.
Isn't it just maybe
But every time we go, last fatality, last near miss, last injury, it's always declared. But what we are saying, if I want to get you right, there's a way of saying these things. Yeah. Because as somebody, John Dianaisen Zapatus and the moon are open, you don't want John John is not allowed to say that.
yeah.
Sometimes if you communication manager is not allowed.
Yes.
Sometimes those things you are referred to the CEO. And the CEO, like last year, the CEO had yes with an incident. right? The swelling is under control. We are still investigating. As we get more information, we'll be advising you. We are doing the same thing, but the jury, what is happening? No, that's what the reporters want.
Because I had a friend.
They should get that.
I had a friend a woman attachment.
Right.
There was someone who had a serious injury.
Right.
So the authority akangopawo supervisor mari kuti angonyarara because zvamusingaripoteje kuti munhu akuwara sei, the truth behind the injury.
And then that's another inform you.
Yeah, they just need to cover up kuti
Yeah, because one of the things I think at our levels we are managers, isn't it? There's information management. So it's one of the key. Because how you report things can damage, can instill fear in the workforce. But now, when just strike, they're checking the background. Production suffers. So there's a way. I think you are right. You are right. You are right. It's the way it was managed. It's the way it's important how we do it. What do you think there's anything I miss there?
yeah, there was.
It was proper. I think those guys they manage the situation because our mind. That's one of the most scary minds that I've gone.
Because they are machinery obsolete as well.
Yeah, and also their ground, even when at this time, to pour my campus, to pour my raincoats. This is the most fearful place that I've gone into a mine because I don't know, but there's gold.
Yeah.
Yeah. I like when I'm fruit and be like we are moving in the corridor. But our mind is different. Yeah. Yeah. I remember that I was in Zimbabwe, there is underground equipment. I can go in the first day. I can push that Jerusalem. No. Now, I'm going
that stuff.
Sometimes, you can have it one day. Yeah. It's all over and above you wait to know, don't think about my records. Yeah, you see. So, but this money. Yeah.
So, Doc, I think this should be assignment number one, using an example of could have a mine or whatever. That's the benefits.
No, you can think about this. You can think about this. CBM can be used, I don't know. Right? In as much we've said all the glory things about CBM, what can be the downside? Condition monitoring tools can be expensive. Sometimes if you want to do on everything, some cases you need to go as far as to make certain modifications to assets so that you can fit monitoring equipment. Right? Because we are talking about advanced CBM, isn't it? So monitoring, the vendor will come and prescribe what you need. And it doesn't come cheap, isn't it?
Yeah.
Choosing the right sensors is not always as straightforward as you might think, though sometimes you do it with the help of vendors, isn't it? Yeah. Think of any system. Do you know, City of Harare at the moment that it doesn't have an accounting software package that's found now? Do you know that? Because many vakauya vakaisa installation of software vakati kana mazotipa mari tozopedzisa and they disappeared. Nobva pauya vamwe vaifunga kuti vakachipa and they did the same because aiwa takubvisa yakaiswa tomboisa trial run mukazobhadhara tozodzoka. So everything is now hanging, right? So issues of partnership and working with reputable suppliers or vendors is very important, right? You need to spend considerable time and money training employees so that they are able to use CBM technology effectively. CBM you can always do your own tests, isn't it? But if now it's like sensor embedded and all that training is now required, sensors might have challenges working properly in a harsh operating environment, especially when trying to detect fatigue damage. Fatigue is something that happens slow, isn't it? Yeah. And you want to know if something is now about to fail. It's tricky.
But can you do it?
Yeah. Fatigue is something that happens very slowly. Slowly. Right? Yeah. Typical my ball joints, my control arm. And once the deal was over, control arm, control.
So I'm saying, can that be detected easily?
Accelerometer. For fatigue, let's say we want to see the axis of our control arm is, then we do the accelerometer.
Right. In service or in stationary or what?
Even in service, maybe the accelerometer connected to the controller of the SCADA system that will send information to the cloud and extract from the software.
So we come to a point where we talk about our 80-20 rule and say this is the failure mode of this component is fatigue.
Yeah.
Then you prescribe what you doses, isn't it?
Yeah.
It cost. Yeah. So it can be done if it turns out to be a problem area, isn't it? Yeah. Okay. Working in harsh conditions also damage the sensors, forcing to replace them on a regular basis. So there's another problem again of sensors needing to be replaced. As you are only doing maintenance, data shows you need to, there's always chance that multiple assets will need maintenance at the same time. This can lead to unpredictable peak times, which definitely challenge your maintenance team. This is the unlikely event that a number of things may actually require to be attended to at the same time, right? Yeah. So, but the long and short of it, the downsides are there. Plan for them, right? Yes, what did you say?
Yeah. Imwe issue yakuita kuti these days vakisa modularization pamaparts. So instead yekumaintaina the whole system, each and every part ine level yanofanira kuzomaintainwa. Saka nemodularization you just remove one part. Then mamwe kana zvichioma less for now, you just remove.
All right.
Yes.
So that's why now they will be on CMP, CPM.
Yeah.
All right. So that's one of those things you can look at. Okay. Right? So, in a nutshell, we've talked about condition monitoring sensors, link them to condition monitoring tools, then CMMS, that's a condition monitoring management system solution. These are some of the packages you can read. So please, when you go through these notes, make your own notes, right? Then we let's go to other things like alarms, notifications, and automation. This is now linked to Internet of Things to enable the condition monitoring system infrastructure to be put in place. Integration with their CMMS, automating maintenance. In what instances would you need to automate maintenance? Do we have such? When?
Normally, sensing machines, everything is automated. Kana pati ya maintain inova tongo ningira. Never to show up a machine. This one need to be maintained. This one need to be maintained.
This one need to be notification.
No
It's
notification.
an alarm, isn't it?
Yeah. But automation.
Does it maintain itself? The machine is.
Pane other process ekuti inoreplanisha yega zvimwe zvinhu ariko but inobva noti
If you have dated the pilot, then you have that since it's like a blockage.
blockage,
The flow rate is not decreased. Maybe you can open the valve automatically
then flash.
So that just flashes out the whole pipe.
Kana oil yakupera inotosenza notokwanisa kutoziva kuti oil yakupera. It has a lubrication through matest anoita inonzi ema-motions. So yakutokwanisa kutoedra oil and stuff.
Is it common in this market?
That's a threat to your company now.
Yeah, these days are common.
If you automate.
If we automate, your company will be under pressure.
You can just be sleeping and saying something.
Yeah. Okay. So the sensor can actually give instruction and it's done automatically.
Yeah, the sensor sends instructions maybe to a PLC controller.
Yeah.
So that knows that if the temperature gets to 90 degrees, what does it do? It opens a valve that has a coolant. Then that coolant will be put into the system. Then it cools down the system till the temperature reaches the optimum level. Once it reaches that optimum level, it sends a command, maybe a voltage command, to close that valve that was putting a lubricant. Then the system starts to operate.
Okay. It's work in progress, and it is Zimbabwe maybe.
Yeah.
Where we go. So can you see? These are areas where you think about your dissertations, right? This other day we had one guy. Was it? This is Savannah Tobago, something like that. Yeah, they're using diesel generator extensively, and so frequently. Vaizvozviziva generator radzinozoti fuel engine yakapera. So the young man was given an assignment to automate the refueling system.
Okay.
Yeah. It's also of interest as well. Yeah. But normally it must give a signal, no fuel.
Yeah.
Shouldn't it?
Yeah, ultrasonic sensor conversations on tracks are level and stuff.
Okay. Yeah. So if anyone to recommend uses numbers to the system, you know that if you generate it.
Nobody never sends that's ultrasonic, you
You see. Okay. So I think for now let's talk notifications and alarms or just a monitor reflection to say this needs attention, isn't it? I know I think it's BP blending plant in Durban. Yeah. We find a number of guys sitting on monitors, actually monitoring the plant. If there's a flash to say this point, there's a problem, then they quickly stop the plant and attend to it. Right? Yeah. So that's one way, isn't it? Okay. And most of our cars, they also show something on the dashboard, isn't it? Yeah. You need need a spanner to look into this, then you know we have to take the car to the garage. Those are the simple ways where condition monitoring is done, isn't it? Yeah. So it depends whether you want alerts, you want automated maintenance, but automated maintenance is being too ambitious, isn't it?
Japan yakutozviita.
There are certain activities, like for instance, if we are
And it is advantages in the long run.
Yeah, but
For the companies to accept it, no,
Mabasa evana vanga ari risk.
yeah, the engineer can justify the financial director. I'm not sure. And then these days, they don't miss their words. They say, Mr. Engineer, you have your resignation letter. No, most definitely come by. So, you can read about this. So, predictive maintenance is still the same. When will the machine break down? I think through our deep learning and all that, you can look at that. What is happening? Tata Pezi?
we just closed. I'm not sure why.
Do you know what's happening? Probably the laptop is dead. I think we are going just to cover 2 slides, the rest I will give you.
Okay.
Yeah. Because they are busy people.
Yeah, of course. I think.
Machine to monitor performance and deployment and more. But this is what we have been talking about, the Durban learning plant, to say somebody is actually monitoring the plant through a computer screen, right?
Yes.
Okay. You can read. So please see how condition monitoring and industrial Internet of Things can be actually taken on board to improve reliability. We've been asking about reliability. It's you, right? So can you see? It's just trying. Reliability is what we want to achieve, isn't it?
Mm-hmm.
Yeah. We don't want accidents. We don't want breakdowns. All that. So your artificial intelligence is also there. So the real-time availability of data, I think that's what we want, isn't it? Right. How big is this group?
Yes, question 3 there is very important.
1, 2, 3, 4. But we don't have about this number 2. Let's discuss. Number 1, number 2, you guys, you put number 3 here. Oh, you're not sure. Right? Number 2 number
3.
Number 3 and 4. Alright? Let's do that. Just 2 minutes.
I think number 1.
Or just talk.
Number 1 is not important. You can leave it.
Or we can just discuss.
It's not important.
Yeah.
Alright, it's fine. So number 2, number 3, number 4. Just 2 minutes. Both of them.